In section 7.4, we're looking at the properties and applications of logarithms. So our objectives today are to understand those properties as an extension of the properties of exponents, because we already know how exponents works. Since logarithms really are just exponents, they're going to work the same way. Also, we want to apply these properties and evaluate logarithmic expressions using the change of base formula. Then we'll want to solve some application problems involving logarithms. All right, we're always going to go back to this. This is kind of like our dictionary between logarithm and exponential equations. Log base answer equals exponent is the same as saying base to the exponent equals the answer. So if you have something like this, like log b of x equals n, it could be rewritten as b to the n equals x, right? All right, so basically, we'll develop the properties of logs by thinking of the number inside here, x, by thinking of it as b to some power, and then any other number inside here, like y, we'll think of that as base b to some power m. Okay, let's go right into these properties. This video will just contain examples and explanations for these properties. Okay, so when you're multiplying two numbers together, taking the log of that product is actually going to be the sum of the two logarithms. Here is why. When you're multiplying two numbers together, if those numbers was like b to the n times b to the m, what do you do with the exponents? You add them together, okay? So because we add the exponents and logarithms are the exponents in the expression, when you take the log of a product, you add the two. This is like n, and this is like m. You add those two exponents together, okay? Similarly, when you're taking the log of a quotient, what do we do when we divide numbers? If they have the same base and written to some exponent powers, you subtract those exponents, right? So it's like we're going to be subtracting the two exponents here. Log base b of the exponent of x would be n, and if the exponent of y was m, then when you divide x divided by y, you subtract the two exponents. Okay? Similarly, if we're raising a power to a power, so if x is like b to the m, and we're raising that to some power r, what do you do with the two exponents? You multiply the exponents, right? So if you're taking x to the r, it's like you're taking the exponent of the value x, which we said was n, and you're multiplying by the other exponent r. Sometimes we imagine that it's like you're taking, when you have something raised to a power on the inside of the logarithm, it's like you're going to put that out front, is how we imagine that working. Okay, the exponents get dropped down. All right, and then here's some, those are the three basic properties. Also, when you're evaluating things, log of 1 is always 0, because anything raised to the 0 power is equal to 1. So the exponent for 1 would have to be 0. Similarly, the log base b of itself has to be 1, because b to what power is b? Well, the exponent has to be 1. All right, and then this is how we convert between when we're using logarithms and exponents as inverses of each other. If you have b to the x, and then you apply log base b of that, then it's like the logarithm and the exponential kind of cancel each other out, and you're just left with x. Another way to think of this log base b of b to the x is like saying b to what power is equal to b to the x, right? That power has to be x. All right, so again, logarithm of the exponential with the same base, the log and the base of the you think the exponential here, they cancel each other out and leave you with just the input there, the exponent. Similarly, b raised to the power log base b, the exponential and the logarithm cancel each other out and leave you with x. Okay. All right, and all of this also leads us to the change of base formula, which can be derived by these ideas above. So suppose you had log of some base that you didn't like, and you would rather write that with some other base. So for example, if I have log base 2 of 5, say, and I'm like, I don't know, 2 to the what power is 5? I'd rather compute that on my calculator, because I can't write that with a base of 2. But you only have these 2 buttons on your calculator. You have the log button and the natural log button. You can use the natural log to calculate this as long as you divide by natural log of the old base. Okay? So that's what this is saying. Log base b of x should be equal to log of any other base of x as long as you divide by log of that new base of the old base. Okay? So we can always scale from any base that we're given to any base that we want using this change of base formula. So again, there's 2 ways to calculate log base 2 of 5 on your calculator. Some of you might have under the math button, some of you guys might have a log base function here under math. I don't have that on my calculator, but I think the TI-84 Plus does. But if you wanted to calculate log base 2 of 5, I would say natural log of 5 over natural log of 2. So that's going to give me 2.321, whatever. And then you can check that by doing the opposite of log base 2 of 5, which says 2 to what power equals 5. Let's plug this in for the power. 2 to the power this number, 2.3219,28095. We get out 5. And it checks out.